Before we jump into any of these compositions is the notation. How do we know we're even composing functions together? So the notation for this, it's going to say f composed with g of x, and it kind of looks like the word fog. It's a tiny little open circle. It also might just say f composed with g and not state the variable x. What this is referring to is f parentheses g of x, where you are taking the equation of g of x and plugging it into f. How is this read verbally? It says f of g of x. And the reason we want to kind of talk about how this is f composed with g, just talking, so when I verbally say that again, you know what I'm talking about. The f of g of x is also equal to that. And we're going to see how that's going to be beneficial as we move through these next few examples. F composed with g, this means that we are taking g and plugging it into your f of x equation. And so instead of just plugging in 2 into f, we're going to be plugging in lots of other things into it. And you've probably seen that when you encountered function notation and would start changing up that x into other variables. So I'm just changing this up a little bit. The first thing that we're going to do is we're going to look at compositions over a table. As you can see, I have the example here of using the tables below, evaluate f of g of 3. And so the best way to approach this is we are going to kind of work backwards with this. So let me just kind of write this out to the side so I have a space to write it in. And so what you're going to do first is you're first going to be faced with looking at g of 3. So I'm going to go to my g table, and I can see that right here is g of x. That means I'm on my g table, and I'm going to go to an x value of 3. Where x is 3, g of 3, or g of x, is equal to 2. So that means if I'm working from the inside out, instead of g of 3, I could write 2, because that's what it is equal to. And now I'm just looking at the f of 2 value. Now we know that notation from our function notation, so I'm going to come over here to my f table. I'm going to go to an x value of 2, and you can see that leads me to a y value of 8. And so you're working from the inside out. First, we started with our g table and went to the value of 3, found out its y value, and then reevaluate it. Now I'm at f of 2, and that led me to the number 8. Let's do it again, but let's look at g of f of 4. So the first thing you're going to do is figure out what is f of 4. Well, you're going to go to your f table. So here it is over here. Look at the x value of 4. Here it is, and that leads you to the f of 4 value to be equal to 1. So I'll write g parentheses, and instead of having f of 4 filled in here, I'm going to have 1, because I found it here on my f table. Now I'm looking at g of 1, so that means I'm going to go to my g table, I'm going to go to my x value of 1, and see what that leads me to, and that leads me to 3. So it's not a lot of computations. I'm not using a calculator, but I am interpreting this. And so the best advice I can give you is start from the inside and work your way out. Let's look at a little bit larger table and see what we can do with it. So we've got lots of different options here as we're going to be jumping around a little bit. What is different with this one is here is the x values. The x values are paired with this f of x value, or it's paired up with this g value. So instead of having two separate tables, they have one large table. But we're going to do the same process. We're going to start with this inner part here. We're going to say, okay, what is g of 7? So you go to 7 on your x and go to its g value, which is 3. So now our next step is to say, what is f of 3? So I go to 3 on my x and then go to my f value, which gives me 8. So again, it's not a matter of adding subtractions. We're not using a calculator. We're not using, the tips. We're not using a whole lot of arithmetic. We're interpreting the graph, and it can be confusing. Let's do it again. First, start from your inside. So you're going to start with g of 5. So you go to 5 on your x and go to its g value, which is 8. So I'll write 8 instead of that g of 5. And then I'll say, what is f of 8? So you can see g of 5 just turned into 8. F of 8, I'm going to do the same thing again. So I'm saying, what is 8 on my x? I'm doing the f of x function, so I'm going to go to 9. So this results in 9. You kind of getting that process? We're going to do it again. So we're going to start with f of 8. So when I come over here, that f of 8 value is going to move into that parentheses. So I go to 8 on my x and go to that f value. So that gives me 9. Now I'm doing g of 9. So 9 is my x. So move to that g value, which gives me a result of 0. We'll do the last two here. So I'm starting with the inner part, f of 3. So I start with 3 and go to my f, which gives me 8. So I'll say, what is g of 8? Start with your 8 and then go to your g, which gives me 4. And the last one looks really confusing because we have an f and an f, but it doesn't matter. Follow the same process. I want f of 6. Whatever I get f of 6 to be is going to go in that parentheses. So I start with 6 and go to f, which gives me 2. Then you're going to evaluate what you have written down now. So now I'm starting with 2. I'm going to move to f, which gives me 5. So this one just didn't utilize the G column, but that's fine. So don't let the notation confuse you. Follow your steps. So this is how we can work and kind of start into compositions of functions when we're giving just a table. The next part is what we're going to do a little bit more of, and we're going to be working with equations. And there's two methods that we can approach this. The first method is using notation like we saw before with our table, where we're evaluating a certain value. And so what we're going to do is we're going to kind of follow those steps like we were doing on the table. First thing we're going to do is we're going to find this inner part. So I want to find h of 1. What I want to do, and this is reverting back to your function notation, is I want to start with my h of x equation, and I'm going to rewrite it with a blank parentheses anywhere I had an x. Then I'm going to plug 1 into those blank parentheses. Now here I can use my calculator or mental math and say 3 times 1 gives me 3 plus 2 gives me a 5, or use your calculator, just type that straight in, and that gives you a value of 5. And so like what we saw with that table, and especially that last example, now we'll say f of 5. So my next step, I'm going to take my f function and I'm plug 5 into it. So I'm going to set up my equation, just like you did with function notation, and then plug 5 everywhere you have parentheses. So I compute that out, and that gives me a value of 20. So 20 would be your final answer for this question. So it is a similar process of what you were seeing with the table. You're working from the inside out. You're finding the inner value and then plugging it into the outer function. But this time we had to do some arithmetic. Now the next method we're going to look at is composing functions, but here's the difference with this. When I'm composing these functions together, I am looking for generic equations. So we're going to have to kind of work through that process and figure out what we're doing with that. So I'm going to give you some more advice on how to work with compositions. Whenever you see a composition of a function, here's the way I like to approach it. I am looking at f of g of x. And so here's how I consider it. F is going to be your template. That's how you're going to set up your equation. So you're going to look at your f equation and write it with blank parentheses anywhere you had an x. Then your g of x is going to be your plug-in. And so you're going to take your g equation and plug that in anywhere you had a parentheses. So I would say x plus 1. Now with this x plus 1 squared, we can't just distribute that squared. That's x plus 1 times x plus 1. So I'm going to have to distribute or FOIL that out, use a box. That gives me x squared plus x plus 1. And we can combine like terms. So that gives me x squared plus 2x plus 1. And so when I'm composing these two functions together, I'm not just getting a 2 or 20 or 5. I'm getting a new equation. This is my f composed with g function. Now I could do more with it. You see that I have f of g of 2 written right here. So if you wanted what is f of g of 2, I could totally plug that in. I'd plug 2 into this equation that I've created. So that gives me, let's see, 4 plus 4 plus 1, so a total of 9. Whereas in the first example, I started with 2, plugged it into G, plugged it into F. This one, I created the composition of the function and then plugged the value back into it. It's helpful to follow that process because I could have multiple questions afterwards. Also, maybe I don't lose a piece in between, so that's why it's kind of considered a second method. Now, the next one I want to do is I want to do G composed with f of x. So again, the first letter is going to be your template. The second letter is going to be your plugin. So we're going to set it up. So G is my template. So I'm going to say something plus 1, and I'm just following this equation. That something you're going to plug in is this next letter, which is F. So I'm going to take my F function, and I'm going to put it in all my parentheses down here. Now with this one, the cleanup isn't bad. I can't really do anything else with it. It would just result in x squared plus 1. But again, follow-up question, we can now plug in 2 into that equation. And so what is G of f of 2? I just plug 2 into this equation I've created. So it gives me 4 plus 1, which is 5. Now what's interesting to note about this is when I composed f and g together, order did matter. You can see that my equations were different. When I went in to find my f of g equation, I got x squared plus 2x plus 1. When I did g first, I got x squared plus 1. So these are not guaranteed to be the same. You can also see not only were they different in their equations they created, but in their answers they created. I got 9 and 5. And so composing two functions together, the best advice I can give you on how to do the setup is to follow template and plug in. Go slow, simplify down, and then if you have to evaluate a number, then plug it in the result. Some of the questions you're going to face is just creation of those equations. Let's keep on this process and keep working with some different examples so you can see how those pan out. So we've got this situation here. It says let f of x equal negative 6x minus 4 and let g of x equal 9x minus 1. Determine each of the following. Make sure to fully simplify your answer. So we're going to work with these two equations and we're just going to see how each of them is going to pan out. So part A, I want to work with f composed with g of x. So that means f is going to be my template that I'm going to set up. So I'm going to say, okay, looking at the f equation, rewrite it with blank parentheses anywhere you have an x. Then g is going to be the plug-in that I'm going to plug into each of those blank parentheses. And so I'm going to say 9x minus 1 and rewrite it everywhere I had a parentheses, 9x minus 1. And then I can clean up from there. So I'm going to distribute the negative 6 into here. So that gives me negative 54x plus 6 minus 4. I can combine those two together, so I get negative 54x plus 2. Now you can see in A, B, C, D, they're just playing with the different orders of those letters. And so let's see how part B pans out for us. So part B says, what is f composed with f of x? So you can see in this one, I didn't have to have two different letters, but it's going to be the same process. So the first letter is going to be your template, and the second letter is going to be what you plug in. So I'm going to set up my template, which is based off f. So I'm going to say negative 6 parentheses minus 4. The plug-in that I'm going to plug in is the f equation again, negative 6x minus 4. Now I want to clean it up. Distribute, which gives me positive 36x plus 24, and I'm going to bring over this minus 4, and then again combine these two together. So it gives me 36x plus 20. So you can see in part A and B, not too bad. You always want to simplify them down. Your answers always need to be fully simplified. In an exam situation, simplified is what's going to give you full credit. You might get partial credit along the way, but the boxed answers are what we are looking for. Let's look at part C. This is G composed with f of x. And so G is going to be your template. So I'm going to first set up that template of G. So I'm taking the G equation, 9 parentheses minus 1, and I'm going to plug in The second letter I see is F, so that's my plug-in. I'm going to plug in my whole F equation, which is negative 6x minus 4. Now I'm going to simplify this up, so I'm going to distribute the 9. The 9 is not going to the negative 1 because 9 is only touching the parentheses, so that's negative 54x minus 36 minus 1, and then I can combine those two together. So I get 54x minus 37. Lastly, we're going to look at part D. Part D gives us G composed with G of X. Again, same process. Template, plug in. So I'm going to say, okay, well then that's going to be equal to, let's see, our G equation is 9 parentheses minus 1. But this time I'm plugging G into itself, so I'm going to write 9x minus 1 in that parentheses. Again, you always clean up to lowest terms, so it gives me 81x minus 9 minus 1, and put those two together. Now those equations weren't bad, they went pretty quickly. I just want to kind of practice with you that template plug-in situation. The next example I want to do with you is because I want to revisit some of those fraction properties and make sure you're on task with those. And so in this one, the first thing I want to do is compose F and G. So when I compose F with G of X, again, following my directions here, that's going to be my template. And so I'm going to say, okay, what is my F equation? That is 1 over something minus 2. Then G is my plug-in. And so I'm going to take my whole G equation and place it in there. Now that's my raw answer. That's those two. They are composed together, but you always have to clean up and simplify, and it's really bad form to leave fractions within fractions. So that means, noticing here, positive 2 and negative 2 are going to cancel each other. So that's going to leave me with 1 over 3 over x. And if you remember how to divide fractions, you keep it, change it, flip it. So you keep the top, change it to multiplication, and flip the bottom. So that gives me, as a result, x over 3 as an answer. When I'm just multiplying by 1, you can see I'm getting x over 3, or 1 times anything is just itself. Now, we could follow up into this question here that says, what is f of g of 4? Now that we have that equation, what is f of g of 4? Then we would just say, well, we're just going to plug 4 into the result we already have. So that gives me 4 over 3. We've done all the work in the composition in the equation. Now we're just plugging in. Now I am going to just leave that as 4 over 3. I'm not going to go into my calculator and find 1.3 repeating. I always want exact answers in proper fractions. I'm not ever going to use decimals unless I'm in an application situation or it tells me specifically how to round. We always want exact answers. Now the next part, we're going to do f of g of x and see how that works out. Because we've already seen that just switching the letters is not going to give us the same answer. So I'm going to start with g. Remember, G is your template. And so I'm going to say, okay, well, if G is my template, that gives me 3 over something plus 2. And then F is the plug-in. And so I'm going to take my F equation, and that's 1 over x minus 2. Now again, that's my raw composition. I do need to clean that up. The plus 2 is going to kind of hang out for a minute, and I just want to kind of address this piece here. This is 3 divided by 1 over x minus 2. And from the earlier example, you can see in order to work that, we're going to say 3 times, so we're going to keep the 3. We can even call it 3 over 1 times, and we're going to flip that second one, so that gives me x minus 2 over 1. When I multiply these two together, and that just gives me 3 times x minus 2. Again, this plus 2 is just going along for the ride. Now, don't cancel next. Go ahead and distribute first. And so that's going to give me 3x minus 6 plus 2. And then I can put those two together. So it gives me 3x minus 4. Now, that's the composition of G and F, but the last part is I want to put the evaluation of it in there. So I'm going to say, what is G of F of 4? And so I'm just taking 4 and plugging it in for that x. So it gives me 3 times 4 minus 4, 12 minus 4, which gives me a total of 8. So compositions can be confusing at times, I have no doubt. If you have any questions, I would first take your notes and go and try all of the homework assignments. Then after you attempted those, reach out to your instructor and let us help you with that. I hope this helps.